been working with me for 2 years now, and we have had tons of fun, tons of discussions. We've worked in making solutions, we've worked in fixing the HPLC and doing plumbing. We've just sat in my office and chit-chatted for hours and hours and hours. And I have felt very, very privileged to work with Lauren and see how she has grown and changed. And I cannot be prouder than to announce her today, and how much fun we had kind of combining my expertise, her interest in ensuring that when she goes on to pharmacy school, which is where she's headed next, out to Austin and pharmacy school, that she's going to create safe products for all of her consumers in the future. And as this is a priority for her, she really wanted to get some of the analytical and really bring in the pharmacy aspect. So we created a project together, and these are the fruits of it, and thank you so much for working with me. I will leave it to her.
Yeah, thank you. Wonderful introduction. So the title of my speech is What's in Your Supplements, an analysis of caffeine supplements. So who here takes a vitamin, mineral, or some type of herb every day? Oh, so a good majority of you. Well, so do half of Americans safely without any side effects, but sometimes supplements don't always go right and there can be issues. For example, in the summer of 2013 in Hawaii, there were a series of unexplained liver cases. And at first, officials thought it had something to do with an environmental factor like a contaminant in the soil or the drinking water, but they were not quite positive. Eventually, these unexplained liver cases were linked to a supplement called Oxylate-Pro. And 6 months prior to this, Oxylate-Pro had actually been recalled by the FDA, and they had actually made a new formula of this supplement. But in reality, the reformulation was even worse and caused all of these liver problems. And as a result of this incident, it resulted in the death of one person. And also, the supplement was supposed to help in losing weight and building muscle, which is why it was so popular. And overall, this ended up resulting in the death of one person, and 2 people required liver transplants. And so you're probably wondering, why do we have these issues with supplements and not so much with drugs? Well, it has to do with how the government defines a drug. In the United States, a drug is defined as a substance categorized by an official pharmacopoeia formality, and it's a substance intended in the diagnosis, cure, mitigation, treatment, or prevention of a disease. So for example, aspirin is a drug, and a pharmacopoeia is basically just a recipe or a standard operating procedure for it. So when people make aspirin, they always follow a certain recipe for it to make sure that it's going to help treat people's pains, and then also aspirin can help prevent strokes and heart attacks. So if we were to say, if we made aspirin and we were trying to sell it in the United States, we would have to go through these phase trials. And so to start, we have this phase 0 phase. And what this phase 0 phase includes is basically the organic chemist sitting in the lab making a number of compounds, trying to see if these compounds have effects on cell lines. After that, they would move on to animal testing to make sure that these have effects on animals and that they're not toxic to the animals. Eventually, we would move on to phase 1, which is checking for safety. So basically, we're making sure that if we give healthy people aspirin, nobody's going to drop dead from taking aspirin. And so this is usually about 20 to 80 people, and like I said before, it's just making sure it's not toxic, and most of the time toxicity issues by this point have been worked out. But there have been some medications where their toxicity has not been worked out. For example, in 2006, there was an antibody that was tested out in, I think, roughly 20 people. And of the 6 people that received that antibody, they ended up having severe side effects, and all of them ended up in the hospital at least about 16 hours later. So, after we prove that aspirin is not going to kill you, we next have to see if it's actually going to help mitigate your pain or not. And this is about 100 people, and it's just checking to make sure that aspirin actually works. And so after we prove that aspirin helps mitigate pain, we next want to confirm our results. So this is just taking hundreds of thousands of people and looking at different demographics. And the reason we do this is because everyone that for every drug on the market, there's going to be 10% of the population that has an adverse side effect. And so in this phase, we're merely looking to make sure that 10% or less of people have an adverse side effect to aspirin. And so after we have confirmed that aspirin is not going to kill you, it actually works at mitigating pain, we can then sell it on the market. And then you're probably wondering how we came up with this phase trial. Well, this is all done by the FDA. And the FDA was first founded in 1930 by the U.S. Department of Agriculture. A big thing for the FDA was in 1937, a company called S.E. Mitiggy marketed a reformulation of their elixir solidified, which ended up killing over 100 people. So the next year, due to public outcry, because people were obviously very upset about being killed by drugs that they thought were going to cure them, the government passed the Food, Drug, and Cosmetic Act of 1938. And then later on, a huge victory for the FDA was thalidomide, which is a morning sickness drug. And the FDA ended up not approving it for the states. The reason being that they didn't have enough evidence for it. And it was a good thing that they did not actually let this go for sale in the United States, because with thalidomide, there are two different forms of it. One form helps cure morning sickness, and the other one causes birth defects in unborn children. And so they'll have deformed arms and legs. And there's a period in Europe, I believe in the early 1950s, where you'll see children with deformed limbs, but you won't see this in the United States because it wasn't for sale in the US at the time. And so, as a result of these phase trials, all drugs for sale in the US needs to be appropriately marketed by the FDA in order to be sold. And so then, how does the definition of a supplement differ from a drug? Well, a supplement is a product intended for ingestion that contains a dietary ingredient, and it's intended to add further nutritional value to the diet. So it's a thing like a vitamin or a mineral. So if you think you're not getting enough vitamin C in your diet, then you would take a vitamin C pill or supplement. And so, if you want to market a supplement in the United States, what do? Well, for example, I have an idea for a weight loss supplement. I know that caffeine helps improve metabolism, and I've heard that kava is healthy from a friend. So I decided to make a 50-50% mixture of kava and caffeine, and then I can simply sell it to people, and I didn't have to prove it was safe or effective. So as you can imagine, this system of regulating supplements probably isn't the best, and so there's been a number of recalls over the years. One example is Purity First vitamins. They were recalled in 2013, shortly after the Sandy hurricane that hit New York. And at first, people thought that this had something to do with environmental factors. Eventually, people actually linked these factors to the Purity First supplements, because patients that were taking these supplements were having a number of adverse side effects, such as lowering of the voice in women, young girls having aggressive behavior, and bloody scales on the head. And so eventually it was found that the people that made Purity First vitamins were contaminated with anabolic steroids. Another example of a supplement that had to be pulled was ephedra. Ephedra in 2001 caused the death of a few football players when they collapsed as a result of taking it. And ephedra has actually been used in Chinese medicine for at least 2,000 years without any issues. But the issue is that there are things called ephedra alkaloids, and the problem is if you have a very high concentration of ephedra alkaloids, these can kill you. And so the reason ephedra is so popular is because it's a fat burner. And so finally in 2004, the FDA decided to ban the sale of ephedra alkaloids. Another example of supplements are just caffeine supplements in general. So if you want to sell a caffeine supplement in the United States, you must contain 400 milligrams or less of caffeine. And this is about roughly 4 to 5 milligrams of caffeine per serving. And the issue here is sometimes caffeine supplements or caffeine powders have too much pure caffeine. And the problem with that is that 1 teaspoon of pure caffeine is equal to 28 cups of coffee. And as you can imagine, that's enough to cause damage to any person. And so you'll end up with a number of side effects such as fluttering of the heart, anxiety, stroke, heart attack, and death. And there was actually there were two issues in the mid-2000s of 2 young healthy men taking caffeine powders, and one of them died of a stroke and the other one died of a heart attack as a result of too much pure caffeine in the caffeine powders that they were taking. And so why are supplements regulated this way? Well, in the early 1990s, the FDA decided that they were going to try to regulate supplements the same way they regulated drugs. As you can imagine, the supplement industry was not very happy about this. and they actually they had a huge campaign to try and counter these measures by the FDA. They actually showed a series of commercials with celebrity appearances, and I'm actually going to show you one of these commercials now.
Tell me about it.
Vitamin C, you know, like in oranges.
If you don't want to lose your vitamins, make the FDA stop. Call the U.S. Senate and tell them that you want to take your vitamins in peace. If enough of us do that, it'll work.
Okay, so you may actually laugh at those commercials. They were actually highly popular, and more people wrote to Congress than they wrote about the Vietnam War. And so as a result, in 1994, the government passed the Dietary Supplement and Education Act of 1994. And as a result, this classified supplements either as a food or a drug. So this meant that supplements couldn't be regulated by the USDA or the FDA before they had to be sold to people. And so we decided to test some caffeine supplements to see if the amount of caffeine on the label matched the amount of caffeine that the supplement contained. So this is just a little brief overview of caffeine. It's a drug of choice among many of us college students. We use it to try and maybe finish papers or finish a last-minute problem set that we can do the next day. And one thing to note about caffeine is that it's an alkaloid structure, so that means it has a ring system with lots of nitrogen in it. And typically caffeine comes from the seeds of the coffee plant, which is native to Africa and tropical parts of Asia. And there's one strain of coffee plant that accounts for about 75 to 80% of all the world's caffeine. And the reason the plant makes this is because it's trying to prevent insects from eating it. And so it works as an insecticide. And so some of the supplements that we tested were E-Boost. And E-Boost comes in a drink or a powder, and it's supposed to provide you with natural energy. What this natural energy is that it's trying to provide it with antioxidants, green tea extract, electrolytes, and green tea. And it's supposed to help boost your energy for the day, and it's for people who want to get more energy out of their day, as quoted by their website. The other one we tested was sledgehammer powder. It's supposed to be a pre-workout supplement, and it's supposed to be the most ultra-potent pre-workout powder concentrate ever, exclamation point. And it's supposed to be some revolutionary pre-workout formula. Now, we never tested this, so I guess we'll have to take their word for it. And so, our methods for telling how much caffeine was in these supplements were, first we ended up using separation. And so, how we did separation is that we used a column with what was non-polar. And after that, we loaded, and this column here, it's called our stationary phase because it's not going to be moving at all. And so after every column, we next load our sample on top. And at this point, we can't really tell where our caffeine is. And so our caffeine is mixed in with many other different compounds. And so in order to separate the caffeine out, we then add our polar mobile phase. And we then can separate out our caffeine, which could be this red band. And so in order to get the caffeine off the column, we will keep running our mobile phase through the column until we get the caffeine off. And so then, how do we measure how much caffeine is in our supplement? Well, we then use detection. And detection essentially is using Beer's law. And Beer's law uses the concentration of the solution. So this is how much we have of caffeine in our solution. And so the more caffeine there is in our solution, the more light it's going to absorb. And then L is just the length of the solution from the light. So this is how far away we have our solution from our light source when we shine it through. And then this is epsilon is our our absorption coefficient, and we multiply these all together to get absorption. And then each compound has like a certain wavelength that will absorb the most light at, and so we can then use this using a spectra. And so this here is a spectra of caffeine. On the x-axis we have wavelength, and then on the y we have absorbance. And looking at this, we can see that 205 and 273 nanometers are where caffeine absorbs the most light. And so when we're trying to determine what wavelength we should set our instrument to make sure that we can get the most caffeine, we would look at the spectra. And so these two methods come together in an instrument called the high performance liquid chromatography. And this is a picture of it right here. And so first what I would do is I would load my caffeine supplements or samples into this auto sampler here. And next what it does is it will load the samples onto a column. And after they've been loaded onto the column, it will pump our solvents, which are up here, through the column and help and separate out the caffeine. So after the caffeine has been separated, we will then use a UV vis detector to detect how much caffeine is in our supplements. And so some pluses of it is that it uses very little solvent and it has a quick separation time. And so from this, we can then obtain a chromatogram. And what a chromatogram is that it tells us at what time the caffeine would come off. And so here is the caffeine. And so it would detect it and tell us that it came off at 2 minutes and absorbed about 5 arbitrary units of light. And so this is just like a summary of our method. So our mobile phase was a 50% mixture of methanol and phosphate buffer. Our flow rate was 1 milliliter per minute, and we were using a C18 column. And our detector was set to 218 and 273. And one thing you may notice is that we have it set to 218 instead of 205. The reason we did this is because one of our mobile solvents, methanol, has a really high absorption at 206. And so in order to avoid that, we moved our wavelength a little bit higher up. And so our sample size is 20 microliters, and our temperature was ambient, which just means it was taken at room temperature. And then we had 2 internal standards. We had one which was spiked with 1 milliliter of 1 milligram per liter caffeine, and then we had them also spiked with 1 milligram per liter benzoic acid. And these were internal standards to try and to see if there was any internal drift, instrumental drift. And what that means is that possibly maybe the UV vis light was flickering, or maybe the flow rate had slightly changed, and so we were just trying to see if there was any changes with that. And so how we found the caffeine in our sample was we had to first find a response factor. And in order to find a response factor, we had to run a caffeine standard, so a known concentration of caffeine through the HPLC. And so we used 1 milligram per liter of caffeine, and we would run that through the machine and obtain this chromatogram, and then we take this area under the curve, and then we would take the peak area, which on one of our chromatograms was 10, and then divide by our standard concentration, which was 1, and get a response factor of 10. And then our response factor is merely just a point on a standard curve, and so it would be just like this one point here. And so typically when chemists are trying to figure out an unknown amount of something in their solution, they will take a series of known concentrations. And so we would have taken a caffeine standard that had 1 to 3 milligrams per liter of caffeine, and then measured the absorption, and then we would have plotted a straight line and then used this formula to solve for it. But in this case, we only did 1 standard, and we just made everything go over to that point. And so in order to find our caffeine, we actually spiked half of our samples with 1 milligram caffeine, and then took the spiked samples and subtracted it from the non-spiked samples for the total caffeine in our sample. And so we would take a chromatograph like this, and so again, we have retention time on the x-axis in minutes and absorption in arbitrary units, and so we would have our benzoic acid here and then our caffeine. And then In the unspiked, as you can see, benzoic acid did not change much, which means that between the two runs, things were mostly the same, and we have less caffeine since there was no spike in it. And so in order to figure out the sample concentration, we would then take the peak area of one of our samples, so one of them maybe was 6, and divide it by 10, and over the concentration of 0.6. And so what we found was for the e-boost powder, we had less than the expected value on the bottle. And for the e-boost drink, we had more. And then for the sledgehammer, we had less than the expected value. And so some issues with our data is that maybe not all the caffeine dissolved into the solution. So one thought is that maybe some of the caffeine was in the filler, because for example, when I was mixing sledgehammer powder, it took a while for all the powder to dissolve. So one thought is that maybe we didn't get all the caffeine out of those powdered supplements. Also, just because they have lower amounts of caffeine may not make them safe, so there may be other metabolites in those supplements that could metabolize from the body and be toxic. And also, overall, we just need to do more testing. So we were only testing one of those products, and so maybe we just got a weird bottle of all of those supplements, and that maybe just by chance they happen to not have the right amount of caffeine in them. But if we took another bottle of sledgehammer powder, maybe we would get 250, which is what we were supposed to get. And so, in conclusion, there are some things you can do to reassure that your supplements are safe. And so you can look for one of these 4 labels on your bottle. And so what these are is they're independent companies that the supplement companies send their supplements to. And what they do is they check the supplements to make sure that what's on the bottle is on the label. And supplement manufacturers actually pay thousands of dollars per year to have these labels on their bottles. And so if you see one of these, it means that it's been tested to make sure that that supplement is up to FDA regulations. And then also, if you experience any adverse side effects from taking a supplement, you should report to the FDA's MedWatch. And what MedWatch is, it's just a place where you can report any adverse side effects. So if you notice bloody scales on your head, you should probably report that. And also, you should let your doctor know so that they can follow up and call MedWatch as well. And then overall, just be wary when buying supplements, since they're not regulated the same way drugs are. And so I'd like to acknowledge these people for helping me with this project. I'd like to acknowledge Deanna for helping me design this. I'd like to help Dave Hall for putting this talk together, and Daniel Martin for letting me take the glassware out of the stock room and borrow things, and then all of Chemistry 680 for listening to my talks when I was starting out. And these are my references. And any questions? Yep.
Do you wish you could have tested even more supplements?
Yeah, that would have been very interesting, because we were initially going to try to do pills too, but the issue is that pills have fillers in them, and then they dissolve worse than powders. So, yeah.
I know some one of the graphs that you had, it was the absorbance versus time. I think it was actually from the HPLC.
Mm-hmm.
It was,
Like
that
this one?
Yeah, you had the large negative peak.
Oh,
for
that's just
caffeine.
like noise
Okay.
or something that's on there. And we actually got that consistently throughout almost every genetic graph that we had.
For the absorbance spectra that you showed, how did you take absorbance spectra for all of the supplements that you tried?
No, we only did it for like a caffeine standard. So
Okay.
we were trying to figure out what light we should use for the UV vis detector when we took the caffeine. And so we only did it on the caffeine standards.
Okay. I was just curious if you take the actual like if you associate the supplements into the liquid form and then just to see what the spectra looked like, and see how close it matched. But then my other question was, how homogeneous was the powder? So did you like shake it up, or did you just like stir it or anything
I stirred it, and I tried to dissolve sledgehammer. Like one time I left it for 5 hours, and then another time I left it like overnight. It still didn't dissolve fully. Cool. At that point. Yeah. And then one of them fizzed. That was fun to deal with. Yeah, e-boost powder, we put it into the Erlenmeyer, or just like start fizzing over.
That sounds good.
Yeah.
There's extra power in it.
I'm just wondering, like, if it's gorgeously, clean caffeine spectrum, then what kind of crap would you see if it actually did the absorption of the actual supplements?
Yeah.
Would you consider using IR or NMR to assay them when they were solid, and then wouldn't have those issues with solving them?
No.
The NMR, you'd have to do solid state anymore.
Yeah, we don't have solid.
Nope.
Yeah, no, we don't have that here. Any other questions?
Let's thank our speaker again. Okay, 15-minute, stretch your legs and get your caffeine supplements.
Or not.
Or not.
Yeah.
Like,
Like, the time's almost